What's up, team? This is Ro, your best friend at JMSB. So here I was asked a COMM 225 production operations management question pertaining to single period inventory. Let's have a look. Question 5. The amount of denim used daily by the Southwest Apparel Company in its manufacturing process to make jeans is normally distributed with an average of 4,000 yards of denim and a standard deviation of 600 yards. The lead time required to receive an order of denim from the textile mill is a constant 7 days. Determine the safety stock and reorder point if the company wants to limit the probability of a stockout and work stoppage to 5%. Now, whenever I'm dealing with a single period inventory problem, the very first step is simply to go through the problem and to identify the variables that are offered to us. And so we're going to do precisely that. We're going to go through this problem, and every time we see a value, we're going to try to identify what the value tells us. So the very first thing that is offered is our average daily demand for denim. We know that on average, each day, we require 4,000 yards, and so D bar is 4,000. The standard deviation of our daily demand is 600 yards. And so sigma D bar is 600. The lead time is a constant 7 days, and so L should be 7. And our service level is 95%. And that's simply because the probability of a stockout is 5%, and so our service level is the complement of that. 1 minus 0.05, 0.95. And now that we've done that, we've identified the variables that are offered. The next thing that I would do is I would use this 95% service level and determine the corresponding Z-score for this service level. I remind you that the service level simply represents the probability that the firm is going to be in stock. And so if there's a 5% risk of a stockout, that's why the complement is the service level, the probability that there isn't a stockout. To get the corresponding Z-score, we're obviously going to need our Z-score table. And think of the service level as the area that is behind the value of Z, on the left of the value of the Z. So if I were to show us a normal distribution, the area that's on the left of my Z is the service level. The area that's on the right of the Z is the probability of a stockout. Now, some Z-score tables give us cumulative areas. Other Z-score tables offer us the area from the line till the middle. In this particular case, we're offered a Z-score table that shows us the area that's from the line until the middle of the graph. For that reason, if we know that our service level is 95%, we should be able to infer that this half is 0.5, and so the area from the line till the middle is 0.45, simply because these two areas are going to add up to this service level. And so the reason we're doing that is because the Z-score table that is offered to us in this case is displaying this area, the area that is from the line until the middle of the graph. And so now the idea is pretty straightforward. We know what the area is from the line until the middle. This area is found inside of the Z-score table. And from the perimeter of the Z-score table, we're going to try our best to extract the corresponding Z-score. So the idea is to scan our Z-score table. We're going to go inside of the table, find the closest value to 0.45. And so I see that 0.45 is right in the middle of these two values, 0.4495 and 0.4505. Now, whenever the area that we're looking for is right in the middle of the two values, I like to take an average of the Z-scores. Some teachers may argue to go to the closest Z-score without going over. So some teachers might ask you to stop here at 0.4495. But in my opinion, it's more accurate to take an average simply because the area that we're looking for is in fact right in the middle of these two areas. And so if we were to do that, realize that the Z-scores are in the perimeter of our table. So it's going to be a z-score of 1.64 and 1.65. If we average those, we're going to get a z-score of 1.645. And as I explained, some solutions might go with a z-score of 1.64 rather than this more accurate answer. So now that we've done that, the next step is to use the equation for the single period model and to calculate the reorder point and the safety stock. So the equation that will be offered to us on our formula sheet is the reorder point R is equal to d bar times L plus Z times sigma d bar times root L. Now in this equation, it's important to know what each piece is telling you. D bar times L is the expected demand during lead time. Z times sigma d bar times square root L is our safety stock. And when we add them together, we get our reorder point. And so now that we know what each of these variables are, we've identified the values that were offered in the problem. Using the service level, we've gotten our z-score. Now it's really just a matter of plugging in the pieces and answering the question. So the question was asking about the safety stock and the reorder point. So we're simply going to calculate those two values individually. So if I were to plug things in here, for D bar I would put 4,000, for L we'd plug in 7, for Z I could put in 1.645, sigma D is 600, and L is of course 7. And we want to evaluate the value of R and the value of safety stock. And so if you calculate that, the answers you should be getting is 30,611.36 for the reorder point and 2,611.36 as safety stock. I remind you that sometimes the solution wouldn't use this more accurate z-score. Sometimes the solution that is reported is using a z-score of 1.64, and had you done that, if you used a z-score of 1.64, now the answers you would have gotten for safety stock would have been 2,603.42, and the reorder point would be slightly different as well. It would be 30,603.42. So that's just a matter of how you are choosing to round your z-score. So I hope that helps. And now let's move on to part B of this question. Let's have a look at what it says here. So here it says, what level of service would a safety stock of 2,000 yards provide? So this time we're sort of doing things in reverse. They've answered what safety stock is, and our goal now is to try to figure out what the service level would be. I remind you that safety stock is simply the latter half of the single period equation. So safety stock can be thought of as Z times sigma d bar times the square root of L. And now what's happening is that we know that the safety stock is 2,000. We know that sigma d bar is 600 and L is still 7. So we're going to first figure out our z-score, and then with the help of the normal probability table, we'll try to determine what service level that Z sort of corresponds to. So once again, if I plug things in, for safety stock, I'm going to plug in 2,000. For sigma d bar, I'm going to plug in 600. For L, we're going to plug in 7. If we solve for our z-score, I'm hoping we get an answer of 1.26, rounded to 2 decimal places. Now once you get this z-score, the next step is to go to your z-score table, look up this z-score along the perimeter of the table, and obtain the area that is displayed inside. So if I go back to my z-score table, this time around what I'm going to do is I'm going to go look for the z-score in the perimeter of my table. So I go look for the first 2 digits in the first column, so I'm going to stop at 1.2, and across I'm going to go until I see 0.06, and now if you simply connect these from inside of the table, you can get the area. So the corresponding area appears to be 0.3962. And so now that you've got that area, understand that that area is the area that is from the line until the middle of the graph. So if I were to show you a normal distribution, the 0.3962 is the area that's from the line until the middle. realize that service level is the entire area on the left of your Z, including this 0.5. And so your service level is really 0.5 plus 0.3962. So the corresponding service level should be 0.8962, or roughly 90%. So I hope that helps and it answers your question. And good luck with your courses, guys. Row out.